Hey everyone, this is Dorita here from Geneva Tutoring Prep for your counseling exam, right? So, if you have not subscribed already, what are you waiting for? Hit that notification button as well so that you can get most recent videos that are coming up. The goal is to post weekly and 1 to 2 videos. So, this topic or this subject has been one of the most requested ones that I have heard from the students that I tutor, as well as just people in the Facebook group community. And if you're not a part of that Facebook community, you have to go and check out the link in the description box. We are almost 6,000 strong there. So let's go ahead and support each other. It's a group that you can feel comfortable talking to your anxieties and worries and also get great free resources. So without further ado, we are going to be doing research. Research is going to be broken down into 4 parts. Why? Because research is already overwhelming enough, so it's best to just break it down and you can always come back to them. So we're going to be doing 25 questions out of the 100. So we are going to start with question number 1. If you have not grabbed the Rosenthal book, whether it's the red, purple, or even just the human dictionary book, just to get some context for definition purposes, make sure you grab it now, pause it, and I'm going to run through these questions and I'm going to run through the answers. So feel free to pause it if you need time to think about what the answer might be so that you can see after you unpause it if you got that right and then go over the explanation of why it's right or wrong. All right, let's get to it. So, question number 1. The most valuable type of research is A, always conducted using factor analysis, B, conducted using chi-square, C, the experiment used to discover cause and effect, and D, quasi-experiment. If you chose C, you are correct. So the whole point of research is to see if what I manipulate, which is the independent variable, will there be a significance of a relationship, right? So cause is me manipulating. The effect is a dependent variable, right? So between these two variables, do they have a significant relationship with each other, right? Another way that I look at it too is looking at this little sheet that I have here. So independent variable is here, right? This is what I manipulate. If you think about independent variable with the I manipulate, right? And then because I manipulate it, I get to see if there are any effects in this dependent variable. So you have two variables, independent variable and dependent variable, okay? Which is also cause and effect. Okay? How strong is the relationship between the two? Is what we're measuring. Okay, number 2, experiments emphasize parsimony, which means A, an interpretation of the results in the simplest manner. B, interpreting the results in the most complex manner. C, interpreting the results using a correlation coefficient. And D, interpreting the results using a clinical interview. So it's going to be A, right? So the whole point of being able to interpret the results in the simplest way is so that you can understand it, right? While making it more complex than it has to be, right? In research, you have your discussion and conclusion at the end, right? This is where you will get more information in the conclusion, right? And then at the end, you will get your discussion, right? Conclusion, what were the results? What were the outcomes? What did you find, right? And sometimes it's vice versa. But the whole point of research is to just explain it in a way that it's understandable. So outcomes raiser suggests that experimenters A interpret the results in the simplest manner. So all these options are literally the same ones from the previous one, but outcomes raiser is the only part that's different here. So if you've already guessed it, same thing, right? Outcomes raiser is to parsimony, right? They both mean the same thing, right? Always think of outcomes razor as a way of shaving down unnecessary information and to get right to the point. A counselor educator is running an experiment to test a new format of counseling. Unbeknownst to the experimenter, one of the clients in the study is secretly seeing a adult therapist. The experiment is A, parsimonious, B, it's an example of outcomes razor, C, confounded slash flawed, or D, is valid and will most likely help the field of counseling. If you chose C, you are correct, right? So unbeknownst to the experimenter, well, that means the experimenter can't account for that, right? And now that becomes an error in the experiment, which all ultimately leads to lack of validity and reliability in the test. 5, non-directive is too person-centered as blank, right? So we know that non-directive person-centered is with Carl Rogers, right? But we don't have to have his name here. So we're looking at key concepts that are relatable to each other, right? So A, psychological testing is to counseling. B, confounding is to experimenting. C, sorry, appraisal is to research. And D, parsimony is to outcomes rating. So run through these and then tell me what you got. And if you chose C, parsimony is to outcomes rating, right? They both have similarities, right? The reason why it wouldn't be C is because appraisal is not research. Appraisal is assessment, and this is research. So they don't go perfectly together, right? Confounding is to experimenting. No, because just because you have experiment does not mean it's confounded, right? Psychological testing is to counseling, right? Not necessarily, right? It'll be different if it says psychological testing is to back depression inventory, right? It'll be more relatable in that sense. An experiment is said to be confounded when A, undesirable variables are not kept out of the experiment, and then B, undesirable variables are kept out of the experiment, and C, basic research is used in place of applied research, and D, the sample is random. So A, undesirable variables are not, right? Keyword here is are not kept out of the experiment, right? Something's confounded or flawed means that there's something in the research that's going to make everything just off balance. In experimental terminology, IV stands for blank and DV stands for blank. We just talked about this a little earlier, right? So let's see if you remember it. So independent variable and dependent variable, right? Independent variable, right? Think about the I manipulate, right? I'm introducing something to this group, right? And then I'm going to see if whatever I introduce or manipulate to that group, will that group have a significant response to what I do, right? To how I manipulate the group. So think about dependent variable as the data or outcome of my manipulation. It's still the same group, but it's almost like a before and after, right? This is also the cause and this is also the effect. A professor of counseling education hypothesized that biofeedback training could reduce anxiety and improve the average score on written board exams. If this professor decides to conduct a formal experiment, the IRE will be the blank and the DB will be the blank. If you chose C, you are correct. Biofeedback, right? So I manipulate, right? I'm introducing something to the group, which is the biofeedback, right? And the DV will be board exam scores. Will they increase, right? And then hypothesize means that I believe there is a significance between the two, between biofeedback and exam scores. Experimenters should always abide by a code of ethics. The variable you manipulate and control in an experiment is called the ADV, B, dependent variable, C, the variable you will measure to determine the outcome, or D, independent or, well, independent variable or IV for short. All right, now I hope you pick D. So, right, so it's I manipulate. You think about that IV, you think about that first I mean, I manipulate that independent variable, right? And once again, I'm manipulating by giving this group the biofeedback training in the hopes that their scores will increase or to see if their scores increase. In order for the professor of counselor education, and when it says D question 708, it's just question 8 because I broke the questions down to start for each chapter at one. So in order for the professor of counselor education, see question 8, to conduct an experiment regarding his hypotheses, he will need to he will need a blank and a blank. All right, so let's look at the answer. He will need to have a control group or an experimental group, right? So when you have research, you typically have like that's often used is two groups, right? The experimental group, right, is the one who will get the manipulation, right? That's called the independent variable. Is the experimental group, right? And keep in mind that it's also the dependent variable, right? Just make sure you know it's not three kinds of groups, but it's just two groups, right? So the control group doesn't get any kind of manipulation because they're there to compare the two groups together to see if there is a difference as well between the experimental group and the control group. In order for the professor of counselor education to conduct the experiment suggested in question 8, the experimental group would need to receive the what, right? What am I manipulating here? What am I adding to the group, right? I hope you chose A and B, right? Because I manipulated the group by introducing biofeedback training, right? And then you go right back to what is the effect of that biofeedback training. That would be the dependent variable, which stands for data. Also outcome, right? Hypotheses testing is mostly related to the work of Adcock, Boyd, Lloyd Morgan, or R.A. Fisher. R.A. Fisher, right? So hypotheses testing is like a hunch, right? You feel that there is going to be a significant difference between the two variables, which is the independent variable and dependent variable. You're going to say independent variable causes D, right? And the goal is to see if there is a strong relationship between that or not, right? Or even if it's a little bit. So R.A. Fisher said that a hypothesis is a hunch or an educated guess, right? Which can be tested utilizing an experimental model, right? In this case, a hypothesis might be that biofeedback raised board scores exams, or that reality therapy reduces dysfunctional classroom behavior in high school students. The null hypothesis suggests that there will be no significant difference. And I always think about null hypotheses as the end meaning nothing. No significance at all. Right? So the null hypothesis suggests that there will be no significant difference between the experimental group, which receives the IV, and the control group, which did not. Thus, if the experiment in question 8 was conducted, the null hypothesis would suggest it would suggest that biofeedback did absolutely nothing, right? There is nothing there. There is no level of significance or relationship between the independent variable impacting and resulting to the dependent variable, right? So we have down hypotheses, also known as alternative hypotheses or experimental, right? So the hunch is known as the experimental alternative hypotheses, and then experimental hypotheses suggest that there will be a difference evident between the control group and the experimental group, right? So if we're looking at this question here, it says if the experiment in question eight were conducted, the experimental hypotheses would suggest that, right? The biofeedback would raise board scores, right? So no means biofeedback would not raise board scores. And then the hunch, also known as experimental or alternative hypotheses, would say that the biofeedback would raise those board scores. And it would show up on that dependent variable as the data that represents that. From a purely statistical standpoint, in order to compare a control group which does not receive the independent variable or experimental manipulation to the experimental group, the researcher will need a test of significance, right? So in research, you have to prove that there is a level of significance and you will need to show that, right? You will need to show, and I'm about to read all that. So you will need to show that there is a numerical research, right? A numerical way of looking at the relationship. Is it a strong one? And we'll talk about that more, right? Is it a small amount of significance, right? All right. And so just to go through it again, you'll need to test for significance, right? And that testing will look like you getting the information from that control group and also getting the information from the experimental group and looking at the information to see if there is a difference. Mhm. You can also get the information right through the mean, mode, and medium, right? Central tendency, and we'll talk about that much later. When you see the letter P in relation to the test of significance, it means, right? A, portion, B, population parameter, C, probability, D, researcher using ethnographic qualitative approach. Now, I hope you chose C, is probability. So probability of error, right? Let me do research. You're always going to have the probability of error, but you want to have the smallest amount of error so that your research will be highly valid and reliable. Now, keep in mind, reliable is a little tricky, right? Just because it's reliable doesn't mean it's valid, right? Someone can do the whole procedure, standard procedure wrong and get the same results, right? For example, and it comes out the same way. So if someone else replicates that same test that was already done wrong the first time, then they're going to get the same reliable results and still not be valid either. Okay. But when you look at the P in relation to test of significance, it's the probability of error or chance factors that influence your dependent variable. So in social sciences, the accepted probability level is usually A, zero point 0.05 or less, B, point, well, 1.0 or higher, C, 0.0001 or less, and D, 5.0. So 0.05 or less. So while we're looking at all the other ones, right? This one's bigger than 0.05, right? And this is yielding almost a perfect, a perfect test, right? It's only like a 1% probability, right? Of there being a chance of error. This is always going to be, well, typically out of 100, right? So if you just take this decimal and move it over, it looks like a backwards 100 or 1,000. Same thing for this one, it'll be 10%. The same thing for this one, it'll be 5%. This will be 50%, right? We don't not want to have a 50% chance of error. So ideally, we are looking for at least, right, an acceptable probability of error is 5% if you move this decimal over. P probability equals 0.05, right? So does it mean A, 5 subjects were not included in the study? B, there's only a 5% chance that the difference between the control group and the experimental group is due to chance factors? Or C, the level of significance is 0.01? Or D, no level of significance has been set? If you chose B, you are right on the money. So remember I said you just move this decimal over to the right and you get like 5%, right? You're trying to get the percentage. Right. So that means that there's only a 5% that the results for the dependent variable are due to chance factors or human error, right? So that means that out of 100, the 95% of that test or the result is accurate, right? Okay, so P equal 0.5 really means that is it A, B, C, or D? So you have time to read it. Make sure you pause if you need to. So let's get to the answer. I'm hoping you chose A, right? So 95 out of 100 times, right? Because 95 plus 5 is 100, right? So remember I said we go off of 100. So if I do the same experiment 90, well, if I do the same experiment, I will get the same results 95% of the time. The other 5% or 0.05 will be due to chance or error, right? This is a really good test, right? The study that would best rule out chance factors would have a significant level, and I mean probability, right, of what? A, B, C, or D. So we're looking at rule out, right? No error, right? So of course it will be 0.001. Take that decimal, move it over. It's a backwards 100. This means that your your research is 99% accurate, right? 1% chance of error, right? And human error, right? So that's a really good test. Now, would I be suspicious if it's only 1% chance of error? A little bit. Think about a pregnancy test, right? A pregnancy test is 99.9% accurate, right? I'd rather take a test that's 99.9% accurate than take a test that has what would we do? 92% accuracy, right? All right. All right. Type 1 and type 2 errors are called blink and blank respectively. We chose D. The way I remember this is the one here means A, the first letter of the alphabet, and then type 2 right here is beta, right? The second letter of the alphabet, right? So when we're looking at type 1 and type 2 errors, we're mainly focused on looking at the result after the study, right? So in summary, type 1 error means rejecting the null hypothesis when it's true. Another word for type 1 is a false positive, right? Remember, we said that null means there is no significance, but if I have a false positive, I'm assuming there is one when I should be rejecting the null, right? So type 1 is a false positive, right? And let me rephrase it. I should be accepting the null, right? But I'm not because I assume my research is right and you can tell me that I'm wrong, right? So think of type 1, false positive, type 2, false negative, right? Type 1 error occurs when you have a beta error A, B, you accept the null when it's false, right? C, you reject the null when it's true. And D, you fail to use a test of significance. So remember, we said type 1 is a false positive, right? So if it's a false positive, I'm going to be rejecting the null when it's true. I'm going to say, I'm going to reject the null because there is a level of significance when there isn't, right? So a type 2 error, right, is a false positive, right? So it's A and C, right? So A is also called a beta error, right? But this also means that you reject the null, right? I'm gonna make sure I have the right one outlined. So it means that you accept the null when it's false, right? So that's that false positive. I'm saying that there's nothing there when in fact it is, right? So a type 1 error means rejecting the null when it's actually true. It means the concluding results are significantly statistically there, right? In reality, right? So that means that you probably interpreted the information wrong, right? And those are the things that you would go through research and determining where the error is. Okay? Assume the experiment in question 8 is conducted. The results indicate that biofeedback helps raise written board exam scores, but in reality, this is not the case, right? So I'm around outside saying, yeah, these biofeedback help raise exam scores, right? But it didn't. So which one would it be? I'm hoping you pick type 1 error because that's a false positive, right? Last one. A counselor educator decides to increase the sample size in her experiment. This will reduce type 1 and type 2 errors. So I'm going to break this down simplest way I could. If you have a bigger parameter, which is like your population sample that you're looking into, it's going to reduce the errors of your studies, of your research, right? Because I can get a bigger population size that'll be more, I guess, the more of a depiction of the population that I'm looking at, right? I can get more people. I increase the research information, right? I increase the validity as well as the reliability of this test. Okay? All right. So we went through 25 questions. I hope this was very, very informational. Please let me know in the comments if you are still having any questions about anything. But I really do love research. I really do enjoy this. So, with that being said, make sure you like and subscribe, and then I will be posting another video probably tomorrow. Right now it's Saturday, June the 15th, and who knows, okay? But the video will be posted later next week. All right. Have a great, amazing night.